What's up, guys? It's Jacob here, and I'm coming back at you with another math tutorial. Today we are doing section 7.1, and this is page 455 of your textbook, and we're going to be doing question 13 and 14. These questions are pretty similar, and you kind of need to use the same sort of tools in both problems, so good to just go over both. All right, so let's just read the first question here. It says, Ray and Ann play in a tennis tournament. The first person to win 2 out of 3 wins the tournament. 2 out of 3 games wins the tournament. How many outcomes are possible? All right, so for this one, you're going to want to use like a visual aid. So if you kind of draw out a web or a map, whatever you want to call it, it helps for this one. All right, so we're going to start it at our point at the tournament. Okay, so after the first game, you can have 2 possible outcomes. This would be a Ray victory, or it would be an Ann victory. Okay, so now let's just focus on the Ann victory. So assuming that Ann wins game 1, and then they play another game, there can be another 2 possible outcomes. Ann can win again, or Ray could win. Now if Ann wins again, then that's one possible outcome, because now Ann has already won 2 out of 3 games. That's it, tournament's over. So now if we continue with Ray winning the second game after Ann has won the first game, then there's another, and then they play another game. There's 2 outcomes of that, where Ray wins again, or Ann wins. So if Ray wins, then he would have won the tournament, because he would have won the best 2 out of 3 games. And if Ann wins, then she would have won the tournament, because she would have won the best 2 out of 3 games. So right there we have 3 possible outcomes. Ann winning in two games, you have Ann winning in 2 out of 3 games, or you have Ray winning in 2 out of 3 games. So now if we focus on if Ray wins the first game, and then they play another game, there's 2 possible outcomes of that. There's an Ann victory and a Ray victory. So just like with Ann, if Ray wins 2 games in a row, then he has won the best 2 out of 3 and has won the tournament. So there's 4 possible outcomes. If Ann wins the second game, then there's 2 possible outcomes of that if they play another game. If there's the outcome of if Ann wins again and if Ray wins again. So obviously if Ray wins again, then he would have won the first game and the third game. So there's his best 2 out of 3. So there's possible outcome number 5. Hang on a second. There you go. There's possible outcome number 5 if Ray wins. And then if Ann wins 2 games in a row after losing the first one, then she would have won the best 2 out of 3 games, and that is outcome number 6. So for this, you just count them up now. So you have 1, 2, 3, 4, 5, 6. So how many outcomes are possible? The answer is 6 outcomes. So obviously using the visual stimulant helps. Kind of helps you picture how the tournament would go. All right. So now let's focus on question 14. Trisha goes to a restaurant to order either a sandwich or a hamburger. She can use mustard, ketchup, or relish. Trisha never has ketchup on her sandwich and never mixes ketchup and relish. How many different combinations are possible? Okay, so with this one, there's a little bit more restrictions, a few more limitations on this problem. Okay, so if you start at the point in which she goes into the restaurant, from there you have 2 places that you can go. She can either order a hamburger or a sandwich. All right, let's just focus on the sandwich for now. So one of the restrictions is that Trisha never has ketchup on her sandwich. So immediately you know that if she orders the sandwich, she can, like one of 2 things that she can put on is the relish or the mustard. Okay? And then let's say she puts on relish, she could also put on mustard. And if she puts on mustard, she could also put on relish. So then another combination is mustard and relish. So remember, this question is different than the other question because it doesn't say how many outcomes are possible, it says how many different combinations are possible. So we have to keep that in mind when we count them up, which we'll do after. Okay, so that's it for sandwich. Now if we focus on the hamburger, she can have 3 primary toppings. She can have ketchup, mustard, and relish. But we know that she never mixes her ketchup and relish. So she can have ketchup and mustard also be a combination, or she can have mustard and relish also be a combination on her hamburger. Okay, so now I'm going to switch colors and I'm going to count up all the different possible combinations. So she could get mustard, she could get mustard and relish on her sandwich. There's 1. She can get mustard on her sandwich. There's 2. She can get relish on her sandwich. There's 3. And then here's one that sort of tricked me the first time around. She gets just a plain sandwich. So that's 4. Okay, now if you look at the hamburger, you get the ketchup and mustard. That's 1. You can get the mustard and relish. That's, oh, well, I guess technically that would be 5. Sorry. She could get the mustard and the relish. There's 6. She could just get the relish. There's 7. She could just get the ketchup. There's 8. She could just get the mustard. There's 9. Or she could get the plain hamburger. 10. So there are 10 different combinations. So obviously you guys can see that by using this sort of web or this diagram, just sort of the visual stimulant with these types of problems, it helps you visualize the problem, and it's easier to count up, obviously, as well. So I hope that you guys enjoyed this tutorial. Good luck on your future math endeavors, and let me just quickly do a double check, and it appears as though this may just be my last math tutorial. So I wish you all a great year in the future, and it's been a blast this year. So for the last time, this is Jacob Power, and I'm signing out. Thanks.